All right, we're going to continue on with normal distribution. So this example 2 says chest measurements of 18-year-old male rugby players are normally distributed with a mean of 95 centimeters and the standard deviation of 8 centimeters. And we're going to answer some questions. So part A says, from a group of 200 18-year-old male rugby players, how many would you expect to have a chest measurement between 87, so here's 87, somewhere down below, and somewhere above 111 centimeters. So we would create our standard deviations. If you remember, one standard deviation is 8 centimeters. So if we look, here is the mean. If we want to go plus 1, we would add 8 to give us 103. If we want to go to plus 2 standard deviation, we go to 111. If we want to go minus 1, we're going to subtract 8. So what we're looking for is, what is that percentage from minus 1 standard deviation to plus 2 standard deviation? So we've identified the percentages here, 34.13, 34.13, and then another 13.59. So we would add up those 3 percentages to give you the probability of 81.85%. What does that mean? 81.85% of those rugby players would fall between 87 centimeters and 111 centimeters for their chest measurements. So now it's saying if we have 200 players, how many of them, so we're going to multiply it by 0.8185, and we get approximately 164 players will have chest measurements between 87 to 111. Continuing on, example 2, part B. It says find the value of K such that approximately 16% of the chest measurements are below K centimeters. So remember, here is your mean, your average, and you have some K value below, and this region right here is 16%. So as a decimal, it's 0.016. And we want to find out what is that length in centimeters. So above in here is 100% minus 16%, which is 84%. So 84% will fall above it. So if we look, approximately 16% of the data falls 1 standard deviation. So if we look at our chart here, and we add up these 3 percentages, this is about 16%, and this is 1 standard deviation. So everything below that is 16%. So in our chart, right here, if I erase it, remember this was the mean, This is 1 standard deviation. Sorry, this should be minus. This is 1 standard deviation. So we're looking for below that standard deviation of 87. So this is 87 centimeters minus 1 standard deviation. So our answer is 87 centimeters. We are able to use a graphing calculator on our exams. So these are the steps that you would follow to do these problems that we just did in the prior videos. So you're going to be using normal CDF with the graphing calculator. So if you want to find out a mean of 40 and a standard deviation of 10, and you want to find the probability that a number is going to range between 37 to 48, what you do is you're going to do normal CDF with your calculator, and I'm going to have a video that's going to go along with this. You have lower bound is going to go on first, so that's 37. The upper bound, which is 48. Then you have the mean, which is 40, and then the standard deviation, which is 10. You would enter those 4 things into your calculator. What you're going to get is a decimal value right here, which is about 0.406. So I'm just going to erase this a little bit so you can see it. So there's that 0.406. So about 40% of the values will fall between 37 and 48. Here's example B. Now we're trying to find the probability greater than 45. So here's the mean. At 40. And we're over here at 45. And we want to find this percentage here as a decimal. What's that percent? So we're going to use the calculator. You'll do your lower bound of 45. Now the upper bound doesn't stop. So a lot of calculators say go 1E99. So you want to put a very large number in. So maybe 8 decimal places. Then you do your mean of 40 and then your standard deviation of 10. So here's what it's going to look like in the screen. And what that percentage is 30.85% of the values will go greater than 45. Example C. Here's your mean. And we're at 26. And it's saying, what is the probability of x less than 26? So what's this percentage here? Is what we're looking for. So in your calculator, what they show is an inspire. I'm going to give you the steps. The smallest number is something very small. So I'm going to put in 0.000001. So that'll be your lower bound. Your upper bound is 26. Your mean is 40. And your standard deviation is 10. When you're done, you're going to get that decimal value. So what that is as a percentage is approximately, moving the decimal 2 places to the right, 8.1%.